Section 7.5, products of two or more radical terms. Radical expressions often contain products with factors that have more than one term. Multiplying such products is similar to multiplying polynomials. Some products will yield like radical terms, which we can now combine. In this first example, we can simplify this using the distributive property. We have a term times a two-term. In other words, similar to a monomial times a binomial, we will take 4 times the square root of 7 times the first term plus 4 times the square root of 7 times the second term, and then simplify. 7 and 11 are both prime numbers. We don't have anything to the second power, each is to the first, so we can simplify that by just multiplying the radicands together underneath one radical and calling it 4 times the square root of 77. In the second term, though, we have a square root of 7 times square root of 7. Combining them underneath a single radical would be the square root of 7 squared, which is 49, resulting in 7. So we end up with a 4 times 7, and simplifying this further, our final answer would be 4 times the square root of 77 plus 4 times 7, which of course is 28. In the next example, we have a binomial times a binomial. We'll use our FOIL method to simplify this. Multiplying the first two terms together leaves us with square root of 8 times square root of 8. Outside terms, a positive times a negative is a negative, square root of 8 times the square root of 5. Inside terms multiplied together, we have a positive times a positive is a positive, so we have a square root of 5 times the square root of 8. And last terms multiplied together, positive times a negative is a negative, square root of 5 times square root of 5. Simplifying, we have square root of 8 times square root of 8. That's square root of 8 squared, which is 8. We have next, multiplying these radicals together, negative square root of 40 when we combine that product of radicals. Similar to the next one, plus square root of 5 times square root of 8, combined underneath one radical, is giving us the square root of 5 times 8, or 40. And the last term, square root of 5 times square root of 5, is the square root of 5 squared, which is 5. Simplifying further, the radicals are similar or like radicals because of them both being square root and having a radicand of 40, but a minus 1 plus 1, they're canceling out, leaving us with 8 minus 5 for a final answer of 3 for that answer. Interesting to note, and something that we'll use very soon, is that notice we started out with binomials that had radicals in them, but our final answer was radical free, something that we will use when we're rationalizing denominators or numerators with two terms. In this next problem, they're asking us to take this radical expression and square, which first we'll rewrite this as an equivalence of 3 times the square root of 7 minus 9 times itself, and then use the FOIL method similar to what we did in the last problem. First terms multiplied together gives us a 3 times square root of 7 times 3 times the square root of 7. Outside terms multiplied together, a negative times a positive would be a negative 9 times 3 times the square root of 7. Inside terms, we end up with the same negative 9 times 3 times the square root of 7. And last terms, a negative 9 times a negative 9 is a positive 81. Now you could have simplified as we went, but just to demonstrate what's happening with the multiplication so that you see the simplification, we have integers multiplied together. That would be a 3 times 3. And if we rearrange this using commutative property, we have square root of 7 times square root of 7, which is square root of 7 squared, or square root of 49, which is a 7. In the next term, we have the integers out in front that we can multiply. 9 times 3 is 27, square root of 7. Likewise, same with this. 9 times 3 is 27, square root of 7, and our 81 on the tail end. Multiplying here, on the first term, we have 3 times 3 is 9, times 7 is 63. These are similar terms. A negative 27 plus a negative 27 is a negative 54 square root of 7 because of these being like radicals, plus the 81. And our final step then, can we simplify further? We have integers that we can combine, which we end up with, adding these together, 144 minus 54 times the square root of 7. In this last example, we have, essentially you can think of this as a monomial times a binomial. We'll use the distributive property to eliminate the parentheses, and that will result in the cube root of 9 times the cube root of 3 plus the cube root of 9 times the cube root of 2. Simplifying this, if we put these terms underneath the same radical and factor while we're at it, 9 breaks down into a 3 times 3, and here's that other 3. Similarly, in this second term, 9 can be replaced with a 3 times 3 times the 2, combining those radicands underneath a single radical. And then going back and simplifying, we're looking for cube roots. This is 3 to the third power. The cube root of 3 to the third is 3. We don't have anything to the third power. 3 is to the second, 2 is to the first. So there's nothing to simplify. This is in simplified radical form. And just to clean it up, we'll put it back together as a 3 times 3, 9 times 2, 18. So our final answer, 3 plus the cube root of 18.